So children, today we have to discuss size of object or distance. Size of object or distance. You see, size of proton. In meter it is given. Size of proton 10 raised to minus 15 meter. Very small. It is 10 raised to minus 15. Think about that. 1 by 10 raised to 15. 1 by 10 is 0.1. 1 by 10 raised to 2 is 1 by 100. 0.01. Like that 1 by 10 raised to 15. Such a small size is the size of the proton. We can't see it. Okay. Such a small particle, base particle, elementary particle. We cannot. So whenever I ask what is the size of proton, you should have an idea. It is 10 raised to minus 15 meter. Okay, children. Size of nucleus bigger than that. Size of nucleus. Nucleus contain proton. So nucleus is bigger than proton. See, 10 raised to minus 14. Then atom will be bigger than that. 10 raised to minus 10 meter. So everybody should have an idea of this length. What is size of proton? 10 raised to minus 15. Size of nucleus? 10 raised to minus 14. Size of atom? Bigger than that. 10 raised to minus 10. So these are very important distances. While we study the other chapters, these quantities will come, and at that time you must know its size. Wavelength of light 10 raised to minus 7. This and all not needed, just for knowing they have written. Thickness of paper, 10 raised to minus 4 meter. Height of Mount Everest. All these distances just for knowledge. How these distances are varied from very, very small distance to very, very big distance. Like the size of galaxy 10 raised to 21. Distance of Andromeda galaxy 10 raised to 22, like that, and universe 10 raised to 24, like that. So the variation of the distance from very, very small distance to very, very large distances we can see here. See, these pages are in textbook. When you get it, you can study from it. Okay, children? Okay. Okay. It is an advertisement.
To the power 15.
Okay. And see, these distances are very important. Everybody should know what is one meant by 1 Fermi. Because in our, when we do problems and all, these distances are very, very important to us. Because every distance we have to convert into SI system. So today you can note this, and tomorrow I will ask this. I think it's given in notebook. I don't know whether, but you can note this. 1 Fermi 10 raised to minus 15 meter. 1 angstrom 10 raised to minus 10 meter. 1 AU. Do you know what is AU, children? What is AU? Anyone? AU, capital A, capital U. Anyone? AU, what is AU?
Astronomical unit.
Astronomical unit. Astronomical unit. It is the distance between what? Anyone? It is the distance between anyone? Earth and Sun. Earth and Sun. Distance between Earth and Sun. 1.496 to 11 meter. What is LY, children? LY. This is a larger distance unit, measurement unit. Full form, anyone know? LY, small letter LY. Anyone? No one. Light year, correct. Light year. 1 light year is 9.46 into 10 raised to 15 meter. See these conversions. That means this Fermi, angstrom, a astronomical unit, light year, they are converted into meter. Meter is SI. unit of distance. So conversion we must know, because when we do problems, we have to convert all quantities into SI system. So sometimes they will give in Fermi, but you have to convert into meter. So you should know the conversion between them. 1 Fermi, see, just look, I will ask this. 1 Fermi, 10 raised to minus 15 meter. 1 angstrom, 10 raised to minus 10 meter. 1 AU, 1.496 into 10 raised to 11 meter. 1 light year, 9.46 into 10 raised to 15 meter. Children, you can note these distances. I am not sure whether it is there in notebook, because some distances I ask them to study from text. Text, any idea you got? When will you get? No idea?
Month last, teacher, maybe.
This month last?
Maybe, if the
Ah.
lockdown is over.
Okay. No problem, but I will be giving notes. But if anything is not given, that just you can copy, go for copying this only for second is enough, or for minute, okay. So these distances are very important, you can note this. Okay, children, noted? Are you having book with you?
Teacher, noted.
Okay, very good. So I will ask you tomorrow these conversions, okay. Question, I'll ask question, okay.
A light year is the distance
Can you hear?
light travels with velocity of 3 into 10 to the power 8 meter per second in 1 year.
Children, can you hear? Our volume?
Sir.
No?
Denoted by small letters
Yes, ma'am.
C,
Yes. I'll increase the volume.
which is equal to 3.08 into 10 to the power
Per
16
sec.
meter.
Per sec. 3.08 into 10 raised to 16 meter, more than this. Okay. Next, measurement of mass.
Is the basic property of matter and a fundamental unit of measurement, since its measurement does not depend on any other physical quantity. The SI unit of mass is kilogram, denoted by small letters kg. We observe the standard kilogram weight used by different shopkeepers. But the prototype of the standard kilogram is supplied by the International Bureau of Weights and Measures, BIPM.
See, children. See, International Bureau of Weights and Measures.
The copies of the standard weight are available worldwide, including national.
This is a National Physical Laboratory, and weight is kept there. See, this is, for example, 1 kg weight. International, that SI unit of mass is kilogram. SI unit of mass is kilogram. So 1 kilogram mass. This is 1 kilogram mass, and see, this is kept in National Physical Laboratory for reference. So actually the shopkeepers keep 1 kg, 2 kg like that. We have seen with the balance, we have seen that. Where is it? This, yeah. Here you see balance. With that earlier time we use balance. Nowadays electronic balance is there, platform balance is there, and this balance also is available in shops, isn't it? So here we use standard masses, and we are not sure whether it is correct. 1 kg, okay, it is written, but it may not be correct. Actually, that should be standardized with the mass kept in National Physical Laboratory. National Physical Laboratory, one mass is kept. And with that, we have to calibrate that, our weights. Okay, you can see that.
However, some objects are either so large or so small that their mass cannot be measured using balances. For example, the mass of heavenly bodies, like planets and stars, or the mass of subatomic particles like electron or a proton cannot be measured by direct usage of a balance. We employ indirect...
Okay, children, how will you measure mass? Tell. What is used to measure mass? Tell. Which instrument is used to measure mass? Muhammad Asif? Which instrument is used to measure mass? Very easy question. And I showed the figure also.
It is a weighing machine.
Weighing machine. Then another.
Common balance.
Common balance.
Electric machine.
Electric
and
balance. Electronic balance. Okay. All these are used to measure mass. What is the SI unit of mass? Kilogram. But you know, very large masses. For example, mass of a star, mass of Earth, mass of planet, very huge mass, isn't it? Can we measure with that balance? Children, can we measure? No, we cannot measure that with our balance. Huge masses cannot be measured. So we use some indirect methods. Indirect method means Newton's universal law of gravitation can be used to measure mass of very huge planet or stars, etc. Which one? Newton's universal law of gravity. Do you remember that law, children? Newton's universal law of gravitation. F equal to anyone? 9th standard you have studied. Anyone? What is Newton's law of gravitation?
Force equal to mass into velocity.
Not that one. m1 m2 by distance square r square കേട്ടിട്ടുണ്ടോ അത് F equal to G അതാണ് then force is directly proportional to product of their masses, inversely proportional to square of the distance between them. That is the universal law of gravitation. We have one chapter to study on gravitation. One full chapter is there, gravitation. So that we will be studying later, and that law is used here to find the mass. Understand? Mass of the planet, stars, etc. So, how will you determine mass of stars, planet, etc.? Which law is used? Tell. Which law is used?
Newton's universal gravitation.
Newton's universal law of gravitation. Okay, but only to know that huge masses, it is an indirect method of measurement of mass, not direct method. So for that we use Newton's universal law of gravitation. Okay.
Next methods and techniques by which we can measure their masses. For example, the mass of heavenly objects can be estimated using Newton's universal law of gravitation, which you will learn later in the course. Mass of subatomic particles, like electrons, can be found by making use of
See, next comes the measurement of very, very small masses. Subatomic particle. Atom, we know, atom consists what all things, children? Atom consists what all things? Atom. Please tell. Electrons are revolving, and
protons,
proton and neutron at the
center. Nucleus.
No, nucleus. Proton and neutron inside the nucleus, and electrons are revolving around it. And subatomic, these are subatomic particles. Atomത്തിന്റെ ഉള്ളിലുള്ള particles, subatomic particles, electron, proton, neutron, these are subatomic particles. Their masses are determined by an instrument known as mass spectrograph. This is the spectrograph, just for knowing. No need to study in detail, but you should know how these masses are measured. With which instrument we measure the mass of a very small particle, subatomic particle. For that we use spectrograph. Understand? Subatomic particles masses are determined using spectrograph. Okay.
Devices like mass spectrograph. In a mass spectrograph, a stream of charged particles, like electrons, in rectilinear motion is subjected to electric and magnetic fields. Due to the effect of the fields, the particles then follow a curved path. Then the radius of the
how the mass is determined, not in your matter of in your syllabus. You just know to study or to measure the size of the mass of subatomic particles. We use mass spectrograph only to know that. But just for knowing, some children may have interest how to measure this and all. Just for that I am telling. Here they have shown in figure the particles are moving along this and electric and magnetic fields are provided. And you know, if a particle is more massive, it will bend more. It will, see, you can see that bend
which is
more.
dependent on the mass of the particle is observed.
So the particle is moving, sometimes particle may move straight, some particle are bending. That means if bend is more, that particle will have more radius. So from this radius, from the radius, if the curvature is more, that means it is more massive, like that. Like that, there is a method to find from the radius they can measure that mass of the particle. Just no need to study in detail, just to know how small masses like subatomic particle masses are measured with the help of mass spectrograph. Only to know that. Okay, children? Next we can see.
From the radius of the path observed, the mass of the particle is estimated. The usage of the unit kilogram is not convenient for measuring the masses of the particles like atoms or molecules. Hence, for measuring the masses of the particles like atoms or molecules, a convenient unit called Unified Atomic Mass Unit, referred to as AMU in short, was established.
Have you heard about this, children? Unified Atomic Mass Unit, U. Have you heard? Mass of this particle, mass of this neutron, mass of proton, mass of electron, they are expressed in atomic mass unit. Heard, children? Please tell. Answer me.
Yes, ma'am.
Yes, in chemistry, le? Chemistry, le? Physics, la, no, where did you study?
Not in chemistry.
Chemistry, okay. So, a unified atomic mass unit, or simply we write AMU എന്ന് പറയും. AMU. Unified Atomic Mass Unit is small letter U. So, mass of subatomic particles or atom, mass of atom, mass of molecule, etc. So, such small masses are not expressed in kilogram because they are too small. That's why we express them in atomic mass unit. 1 AMU, how much it is, do you know? 1 IMU, and that conversion also you should know. 1.66 into 10 raised to minus 27 kilogram. So conversion you should know, but usually the masses are expressed in this mass of the subatomic particles or atoms, etc. are expressed in AMU. So another thing that you have to remember is this. What is AMU? AMU is the unit used to express mass of subatomic particle or the mass of atomic particles, molecules, etc. Okay.
The symbol of unified atomic mass unit is U. One unified atomic mass unit is defined as mass of 1/12 the mass of an isolated atom of carbon-12 isotope, at rest and in its ground state, including the.
This definition also you must study. What is meant by one unified atomic mass unit? It is defined as the mass of 1/12 mass of an isolated atom of carbon. Carbon atom base item. So 1/12 mass of carbon atom which is at rest and in ground state, including the mass of electron, it is considered. Electron mass also is considered. Electron mass Why including the mass of electron says? Because mass of electron is very, very small, 10 raised to minus 31 kg only. Such a small mass is that. So, but when we consider here, then mass of the electron also is considered. 1 by 12th mass of carbon atom. What is IMU? One is waiting there. Basi coming. Okay. So, children, what is the definition of 1 IMU? 1 IMU, 1 by 12th mass of carbon 12 atom. 1 by 12th mass of carbon 12 atom. Okay. Including the mass of electron which is considered. Always remember what is 1 IMU? 1 by 12th mass of carbon atom. Which carbon isotope is there? So we have to take carbon 612. 6 is the atomic number and 12 is the mass number. Okay. So just remember that. What is 1 IMU? Okay. All these are important points, children. I have given in notes.
6 into 10 minus 27 kilograms.
This is what I told. Very important relation because mass of an atom or subatomic particle will be given in U. But you should know how to convert into SI system. And everybody should remember this formula. 1 IMU or 1 U equal to 1.66 into 10 raised to minus 27 kilogram. Relation connecting IMU and kilogram. 1 IMU, tomorrow I will ask all these children, next class, not tomorrow, next class I will ask all this conversion. Now we have studied so many conversions. So that and all you have to study well and come. Okay.
The masses of different objects we come across in the universe have a huge variation. The table that follows shows the range and the order of the mass.
Yes, you can see, as we have seen, the distances, very large distances, we have seen very small distances like size of an atom, size of a nucleus, size of proton, etc. we have seen, and a huge universe size, etc. all we have seen. And here it is about mass. The last that table was about length. Now this table is about the mass. You see, very small masses. Electron, 10 raised to minus 30. Proton mass, 10 raised to minus. See, these are important. You must know. No need to refer. Without referring anywhere, you should be able to tell what is the mass of electron, 10 raised to minus 30. What is the mass of proton, 10 raised to minus 27 kilogram. Understand? Then which is needed? Then more Earth is 10 raised to 25, Sun 10 raised to 30. See, electron 10 raised to minus 30. Sun, very huge, 10 raised to plus 30, very big, no? Compare their sizes. Galaxy 10 raised to 41 kilogram. Universe 10 raised to 55. Such a huge it is. So just to know, just to have an idea, human 10 raised to 2 maximum, 100 kg. 100 kg. Automobile 10 raised to 3. Aircraft 10 raised to 8 kilogram. So you should have an idea about this. Whenever I ask what is the mass of universe, don't tell a minus here. Universe size is very, very big now. So no need to have such confusion. Very small distances are 10 raised to minus, very small distances. But big sizes, 10 raised to plus value you have to tell. Children usually make that mistake. So minus value, if it comes as an exponent, that means very, very small. Plus value, very, very big. Okay. So this electron mass, proton mass, you must know. Electron mass 10 raised to minus 30 kilogram. Proton mass 10 raised to minus 27 kilogram. Okay. And the things not much needed. Okay.
Masses of different objects. Measurement of time is of utmost importance for us in our day-to-day life, and even in the history of science. Measuring time gives the chronological order of events that take place and helps in better conception and factual understanding of science. Measuring time is measuring the time interval between two events. For example, in a marathon race, the time interval between the instant of start of the race
marathon race. See, time interval we have to know.
Crossing the finish mark is essential to declare a winner in the race.
So that
ordinary watches, the devices that we normally look at to know time.
Children, how will you measure? So now we have studied length measurement, mass measurement. Next is time measurement. How will you measure time, children? What is used to measure time? Tell. All these are knowing. You are knowing all this.
Seconds.
Time, and the second is unit. Instrument used to measure time. Instrument, watch we can use. Clock, പിന്നെ സ്റ്റോപ്പ് വാച്ച് കേട്ടിട്ടുണ്ടോ? ഹാവ് യു ഹേർഡ് ഓഫ് സ്റ്റോപ്പ് വാച്ച്? സ്റ്റോപ്പ് വാച്ച്,
Teacher.
യെസ് ഓർ നോ? Stopwatch, I will show you. Yes, in that even for example, for these competitions and all, we use stopwatches. So we can even seconds difference we can understand in that seconds. So stop watches, clocks, stopwatches, etc. is used to measure time. Okay, I will show.
Do not help in deciding the winner, as the events of two persons crossing the finish mark can vary in a fraction of seconds. To increase the accuracy, we require the time measuring devices that can measure the smallest fraction.
See, this is the stopwatch. Even the smallest fraction of a second, it is divided. So even smallest fraction of a second can be seen in stopwatch. So more accurate than our watches. It is more accurate than our watches. Okay.
Fraction of a second. Standard SI unit in measuring time. There were so many kinds of time measuring devices used in the past, ranging from hourglasses, pendulums, sundials, etc., which measure time based on different phenomena. To have the most accuracy in measuring time, now we use an atomic standard of time, which is based on the periodic vibrations produced in a cesium atom.
Cesium atom.
Hence, the clock is also referred to as the cesium clock or the atomic clock. In a cesium clock, a second is taken as the time needed for 9,192,6.
Children, here for most accuracy nowadays, in the laboratory and all, they use cesium atomic clocks. It is very, very accurate, and it can be used anywhere in the universe, that as a standard one, cesium atomic clock, because the vibrations made by cesium atom, this much, see, it is given, it is the actually definition of 1 second now. That means a cesium atom, it is vibrating, and the time needed for 9,192,631, 770 vibrate, this much a big number, no need to study by heart, just for knowing all this are telling, no need to study by heart. So this much vibrations the atom, cesium atom make between the two transitions. This much vibration is making 1 second, children. So everywhere in the universe, cesium atom, this much vibration is same. Time taken for this much vibration is same everywhere in the universe. It is not changing with the time, place, or other circumstances, not changing with that. So this much vibrations will make 1 second. That is the definition for second now. So cesium atomic clock is used. Why, children? It is internationally accepted. It will not vary with other factors, and the number of vibrations made by the cesium atom that this much vibrations will constitute 1 second. That is not varying. So you no need to study all this number. Don't worry about that, seeing all this. I just showed that instrument. Understand? You should know only one thing. cesium atomic clocks are used to measure time accurately. Only to know that. cesium atomic clocks. Why atomic clock? They are more accurate. That's why. Only to know that. Okay?
770 vibrations of the radiation corresponding to the transition between the two hyperfine levels of the ground state of cesium-133 atom. The vibrations of the cesium atom regulate the time shown by this atomic clock.
Okay, okay, children. So I will show you the notes then, because you can study that. 5 minutes I will show you that. Okay. Now measurement of mass, time, everything is over, and the notes, corresponding notes we can see. Okay, children. So you can write in your notebook. I think everybody is writing the notes. And if any doubt come, you have to ask. Now I think all are there, 37. Parallax method we have seen. Yesterday, problem is there, no, that I will explain later. Size of molecular folic acid, that also we have seen yesterday. Range of length, this is what I told. 1 Fermi, 1 small f, 10 raised to minus 15 meter. 1 angstrom, 10 raised to minus 10 meter. 1 astronomical unit, 1.496 into 10 raised to 15 meter. 1.496 into 10 raised to 11 meter. Okay. 1 light year, 9.46 into 10 raised to 15 meter. Distance traveled by light in 1 year. Distance traveled by light in 1 year. What is the velocity of light, children? Anyone? Velocity of light? Lakshmi, what is the velocity of light? Lakshmi Biju. What is the velocity of light? Anyone? What is the velocity of light? Nobody knows. 3 into 10 raised to 8 meter per second. So, distance that light travels with a velocity of 3 into 10 raised to 8 meter per second in 1 year. In 1 year, distance traveled by light, what is the velocity of light? 3 into 10 raised to 8 meter per second. With that velocity, light travels. And how much distance it travel in 1 year? That is light year. Distance traveled by light in 1 year. That is 1 light year, children. Parsec. Parsec is the distance at which average radius of Earth orbit subtends an angle of 1 arc per second. So you conversion you study, explanation I will show you with figure. Okay. Parsec 3.08 into 10 raised to 16 meter. These distances I told you should know the conversion. Light year, meter, parsec, meter, conversion, as AU, meter, conversion. So all of you have to study these numbers, no, conversion, very well. Measurement of mass. Mass is measured with common balance, and its unit is kilogram. Large masses like that of planets, stars are measured gravitational method, universal law of gravitation. Very small masses like atomic particles are measured using mass spectrography. ഇത്രേ അറിയാനുള്ളൂ, അതാണ് ടീച്ചർ കാണിച്ചു തന്നത് കേട്ടോ, ഇത്രയൊക്കെ അറിയാനുള്ളൂ. Then AMU, what is AMU? Next. 1 AMU. One AMU is 1/12th mass of an atom of carbon, C612 atom, including the mass of electron and its conversion. And ഇത്രയൊക്കെ അറിയാനുള്ളൂ. 1.66 into 10 raised to minus 27 kilogram. How many? 36 are there. 2 absent. Measurement of time. cesium clocks are used. They are also called atomic clocks. They are very accurate. And used in National Physical Laboratory.